Welcome to Section 7.3. In Section 7.3, we'll be multiplying powers with the same base. For a warm-up, let's circle the base in each of the expressions. And then for number 4, we want to write an expression with an exponent 4 and a base 3. Is the student's expression 4 to the third correct? And explain. Remember, the base is the big number. So we would circle the 5 in the first problem, the negative 3 in the second problem, and the n in the last problem. If we want an exponent of 4 and a base of 3, we would want to write 3 to the fourth power. So this student's expression 4 to the third would be incorrect because this student has 4 as the base and 3 as the exponent. Our vocabulary word for today is repeated multiplication. Repeated multiplication refers to the same number being used as a factor more than once. For example, the expression 5 times 5 times 5 times 5 shows repeated multiplication because the 5 is used as a factor more than once. Let's take a look and see if we can figure out the pattern by filling in the blanks. The first one here, we have 3 to the second power, which means we're taking 3 times 3, and then multiplying that by 3 to the third power, which means we need 3 3's. So how many 3's do we have all total? Hopefully you said 5. So this would be 3 to the fifth power. How many 5's do we need for 5 to the fourth? Right, we need 4 of them. And the second one there, 5 to the second power, we would need 2. So giving us a grand total of 6 5's. Here we have 4's 3 times, and 3 more 4's, giving us a grand total of 4 to the sixth power. Let's take a look at the last one here. We need 3 2's and 2 2's, which gives us a grand total of 5 2's. Let's do this one on our own. How many 3's do we need? Sorry, how many 6's do we need? 3 of them. And how many 6's do we need for the second one? 4 of them. So all total, how many 6's do we have? 7. Do you notice a pattern or some sort of rule for what's going on here? Hopefully you notice that we're taking these exponents and adding them together to get our answer way over here. Notice that the base, 3, 5, 4, 2, 6, those all stay the same. The only thing that changes is the exponent. So, the rule for multiplying powers with the same base is to keep the base and add your exponents. For example, 4 to the third times 4 to the fifth would be 4 to the eighth, because 3 plus 5 is 8. b to the seventh times b to the negative fourth would be b to the third, because 7 and a negative 4 is going to equal 3. Let's compare using greater than, less than, or equal to. So here we have 6 to the fifth. Nothing that we do need to do there. Here we have 6 to the 6 minus 4. Well, 6 minus 4 is going to be 6 to the second, so which one's going to be bigger? Well, 5 6's would be bigger. Here we have 8 to the 2 plus 9, so that's going to be 8 to the 11th power. And here we have 8 to the 12 minus 1, that's going to be the 11th power. So these two are going to be equal. Here we have 3 to the 7 minus 6, which is 3 to the first. Here we have 3 to the 0. So we have 3 to the first and 3 to the 0, so 3 to the first is going to be bigger. And finally, in the last one, we have 1 to the 7th and 1 to the 0. Well, in this case, 1 to the 7th is going to be 1, and anything to the 0 power is 1, so these are actually going to be equal. So, multiplying exponents with the same base. Again, when you have the same base, you're going to keep your base A and add your exponents. So again, for example, 3 to the third times 3 to the fourth. We could write this out as expanded and get 7 3's, or we could just add the exponents together. If you have letters, same thing. Keep the base of n and add the 2 and the 4 together to get n to the sixth. Again, multiplying powers with the same base, you're going to keep the base and add the exponents. In this first one, we have a 5 and a 3, which gives us 8. Here we have 9. Remember that there's a 1 here, even though it's not written. So 9 and 1 gives us 10. Oops, too far there. Okay, so let's take a look at some examples. So here we're multiplying. Notice that in every problem here, they all have the same bases. So we're going to keep our base and add our exponents. So m to the 10th. This would be 10 to the 11th power. This would be 5 to the 8 plus 5 is 13 plus 6 is 19. And this last one's going to be k to the 21. Good. Let's try some of these. Try these on your own and then check back to see how you did. Let's see how you did. So, the first one, hopefully you have n to the 8th. The second one, k to the 5th. Here we have y to the 12th. And this last one was a little bit tricky. What's 2 times 4? 8. And then a times a is going to give us a to the 5th power. How'd you do? Let's take a look at some more examples here. Let's use Chucky here. So we're going to have 4 times 9, which is 36. And then I always take care of the numbers first. And then from there, I take care of the letters. So this would be z to the negative 7th. Now we don't want to leave a negative exponent. Remember the rules for that? Goes to the bottom. Let's try another one. Let's try Angelica. So here we have 3 numbers, so we're going to take a negative 4 times a positive 7, which is going to give me negative 28, times 2, which is going to give me negative 56. C to the 3rd, D to the 2nd, and C to the negative 2. I can only multiply them if they have the same letter. So I'm going to be able to multiply the C to the 3rd and the C to the negative 2, keeping my base and adding my exponents. The d to the 2nd doesn't have anything to get combined with, so it's just going to stay. So negative 56, c to the 1st, d to the 2nd. And let's try Chucky. So here, we're going to multiply the 3 numbers. So 2 times 9 is 18, and 18 times 3 is... we have 24, carry the 3. 3 times 1 is 3, plus the 2, 54. So 54 for our number. A and A can be combined to give us A to the 3rd, and the B to the 4th is just going to tag along. Homework assignment is on page 429, numbers 9 to 27, the odd ones.